In Part 1, we saw the challenges faced by health system managers trying to make digital health applications work for their health programs, and left off with Lucy and Isaac struggling to get their applications to exchange data. Now in Part 2, we will examine the way Lucy and Isaac initially try to solve this data exchange challenge, but face problems with this approach later. When talking to the ministry's software development team, Isaac and Lucy learned that they can directly integrate the two applications, DHIS2 and OpenLMIS, to enable communication of data. They explain that to integrate the two applications, they will need to write custom code between the applications to translate how the data is being described by each application using a bidirectional connection. This sounds like a good strategy for solving this simple use case. However, Isaac doesn't just manage immunization, but all the health programs in his district, many of which are supported by their own applications that could benefit from communicating with each other. And Lucy doesn't just work in this district, but manages the whole country's immunization program. And she needs many other districts' applications to be able to communicate as well. So Lucy and Isaac asked the software development team about integrating their other applications. When working with the team on integrating the larger set of applications, they encounter new challenges. When they connected just two of their applications, OpenLMIS and DHIS2, they needed just one bidirectional connection to exchange data, so the cost was low. However, this problem compounds when you add additional applications. When they add a fourth system, they need to maintain 6 bidirectional connections, and a fifth needs 10. And if one application changes, all the other applications need to change as well, since they are now connected. This is extremely expensive and will quickly use up their entire budget. Why does the cost and complexity rise so significantly with each additional application? The software development team explains that it is due to a problem known as the quadratic cost problem, named after the mathematical concept they illustrate here. The number of bidirectional connections increase quadratically, not linearly, with each integration of a new application. When you have a country with as many systems as Onessa, by the time you need any more than 3 applications, the cost and complexity rise much faster than the number of digital health applications you are trying to connect. There must be a better way. Integration is not sustainable. Writing software to directly connect to applications, or integration, may be able to connect your applications, but there will still be the quadratic cost problem. Is there a way for multiple applications to communicate with each other that addresses the quadratic cost problem? Yes, we will explore this in the next part.